Alrighty, we're looking at exam week. For exams this week, keep in mind Wednesday, Thursday, Friday this week, we're looking at exams. The breakdown of that goes by your schedule. So the Wednesday is your 3rd and 4th hour exams. Thursday, 5th and 6th hour. And then Friday will be your 1st and 2nd hour. So go by the scheduled hour that you have this class for your exams. And that's going to be the day, the time that you're scheduled to take it. So I'll put some more details in Google Classroom about that, just so you know exactly what I'm talking about. But that's the general plan there. So we're looking at some factoring and some simplifying problems. So all kind of just key skills going forward. For factoring, you see A is not 1, and there is no GCF here. So when A is not 1, that's when you have to do AC factoring. So our AC in this case is negative 30. And we need factors of negative 30 that add to 1. So that would have to be 6 and negative 5. So this is the one where we can't just say x plus 6x minus 5. That's not going to work because that'll never give you this 2 here. So this is the one where you have to rewrite that middle term. So you rewrite it as plus 6x and minus 5x. So because this is still equivalent to 1x, but you just choose the factors that you selected here. This then allows you to do grouping with our first and last terms, our first 2 and last 2, and take the GCFs out of those. So out of here, I can take a 2x, leaves me with x plus 3. Out of this, I can take a negative 5, and it'll also leave me with x plus 3. Now, if you remember, these should always match, because now your factored form is the 2 GCFs combine to make one factor, so 2x minus 5, and the common parts combine to make that other factor, x plus 3. And so that'd be our factored form. Beauty of this stuff is, keeping in mind multiple choice tests and stuff, you could always check this answer. If you want to see if this is equal to this, just distribute it. You know what I mean? Like, there's 2x squared. There's a plus 6x. There's a minus 5x. And there's a minus 15. And those combine to be plus x. So 2x squared plus x minus 15. Boom, that matches up. Keep that in mind. If you're looking at choices, multiple choice, and one of those has to be the answer, you could always go that route to find it too. And that's true for a lot of things. All right, so next one. Distributive property with imaginary or complex numbers in this case. So we're still going to do our distributive properties. We're going to do 3 times 4 is 12. 3 times a negative 2i is a negative 6i. This will be a plus 4i. And this will be a minus 2i squared. So the I squared is really the crucial piece here, because you have to remember that I squared is equivalent to negative 1. Anywhere you see an I squared, you can replace it with a negative 1. So what do we actually have here? We have 12, and then negative 2 times negative 1 is really going to be a plus 2. So we have 12 plus 2, which is 14. That's our real part. Then we have negative 6i plus 4i, which is a minus 2i, and that's our imaginary part. On to division here. With division, this is the one that has the little bit of a funky rule that instead of actually doing the division, because that's complicated, what we do is we do a little move where we take whatever the complex conjugate is here. So that's all you gotta do is change the sign in the imaginary part. So we're gonna take 3 plus 3i over itself as a fraction. And so we're not changing anything here because this is just multiplying by 1. It's legal to do. But what this is gonna do is it's gonna make things simplify pretty nicely. So let's see. So it's really just a big distributive property problem. You're going to do distributive property on the numerator and on the denominator. You're going to see how things shake out. So we're going to get 12. We're going to get 12i. We're going to get 6i. And 6i squared. Okay, we'll simplify that in a sec. I'll go ahead and do the same down here. We're going to get 9. And then I always skip this part because I know they're going to match, but you don't have to. But you notice you're going to get 9i. And a minus 9i. Because you've designed these to cancel, the imaginary part is always going to cancel. So I don't even bother writing them because I know they cancel each other out. So then I just move on to the last part, which is negative 3i times 3i, which is a minus 9i squared. So technically, if you want to write the plus 3 or plus 9i and minus 9i, you can, but they're going to cancel out anyway. So I always just skip past it because these are conjugates. That's the whole point of it. All right, so what are we working with now? Remember, these I squareds are negative 1s anytime we see them. So this is going to be just a minus 6. So 12 minus 6 is 6. 12 plus 6i is 18i. Cool. And this is going to be a positive 9. So this is 9 plus 9, which is 18. And so now we're pretty much done. We just got to reduce that fraction. And Since all of these coefficients are reducible by 6, we can divide every piece of it by 6 to reduce it to 1 plus 3I over 3. And that is going to be our final answer there. And the goal is with these, you should always have a real number in the denominator, nothing imaginary. That's kind of when you're done with a division problem. All right, so again, I just kind of picked some of the tougher key skills we've worked on this year, and hopefully that's helpful for you.